So we're going to talk about all different types of numbers, names of numbers. Does anybody know what the numbers are that 1, 2, 3, 4, 5, 6, dot, dot, dot? Anybody know what the name of those numbers are? Starts with an N. Not a lot of people remember this one. It's natural numbers. And then see how this is a circle here? And then we've got the natural numbers inside. So all these numbers, and then if we add a 0, anybody know what the name of that is? Starts with a W. So whole numbers. And then what other types of numbers do we have? What's that? Okay, and they would be included in these here, but what numbers have we not talked about? What's that? Decimals, you're right. So they're going to be in a different circle, but I like your thinking. So you said something to me about a name of numbers. Can you tell us what that was that you said? Integers. So it's going to be integers. Anybody else? Anybody know what other numbers would be included in integers? Negatives. That's right. So dot dot dot. -3, -2, and -1. So it keeps going on forever in the negative direction. So then you said decimals. Good. So a decimal like 0.789. Any other decimals that we have? Or anything else that we have? Other types of numbers? We have fractions, that's right. So let's say 21/8, for example. These are just examples. So fractions and decimals. The fractions and the decimals have to be specific types of decimals. So the decimal, for example, 1.333 with that 3 repeating is included in there. So that is a repeating one, and that if we, I'll tell you in a second, the names of these are called rational numbers. So now that you're in Algebra 2, we expect that you'll know these names. And the name for rational numbers, the definition, is any number that can be written as the ratio of 2 integers. So remember, the integers were all of these numbers here. And what does ratio mean? So it's going to be like, in this case, it could be a ratio could have a colon, it could have a division symbol. Here we're going to talk about a division symbol. So for example, 21/8 is a ratio of 2 integers because it's got 21/8. So how would we get 2 to be the ratio of 2 integers? What would 2 be equal to? 2 over what number? 1. 2 over 1. And we could have other numbers that equal to, like 4/2, for example. So those are rational numbers. So what are some other numbers besides those? That's going to be a separate one, but good thinking. Yes, we will get to imaginary numbers. What are some other numbers that you have seen before yesterday? We talked about imaginary numbers. What did we talk about the day before yesterday? What were we doing? Or even yesterday, we did some like this. What were we doing yesterday? Square roots. So we want specifically for the irrational numbers, we want specifically like a square root of 7, for example. Something that you can't take the square root of. That would be an irrational number. If we have a decimal for a real irrational number, make this eye a little clearer. That decimal is a decimal that goes on forever with no patterns. Anybody have any idea of another irrational number? Pi, yes, good, pi. And lots of others. So those are irrational numbers, and irrational and rational make up real numbers. Those together make up the real numbers. So up until yesterday, that was all you knew about were real numbers. And then yesterday, we introduced what other type of number? Imaginary numbers. So imaginary numbers comes over here. It's an example of an imaginary number. What's an example of an imaginary number? So, what's an example of an imaginary number? So it's square root of -1, so it's just like I. So it can have something in front of it, say 8i or I square root 7. That would be an imaginary number, right? So it's just an example. So now we have another type of number. And the other type of number are complex numbers. So complex numbers encompass everything. Real numbers are complex numbers, imaginary numbers are complex numbers, and we have what are a combination of both a real and an imaginary part. And so that's what we're going to work on today, like 5 minus 11i, for example. Got a real part, the 5, and an imaginary part, the -11. Okay? So complex numbers, what we're doing today. Yesterday was just an imaginary because it just had the I. Does that make sense? Okay, so complex numbers need to be in standard form, which is a plus bi. In the standard form, the a is the real part, and the bi is the imaginary part. The complex numbers have a real part and an imaginary part. Okay, so we're just going to do adding and subtracting complex numbers today. Anybody still looking at this here? Yes. So sorry, not very exciting talking about all the names of numbers. I hope you have heard at least the phrase real numbers, or rational numbers, or irrational. Okay, so here's our first example. We can go back if you need me to later. What do you think we might do with -2i plus 6i? Just add them. We're going to add the -2 plus the 6, which add to 4. So it's 4i, just like if there was a variable there. So what do you think number 2 would be?
-3i.
Yeah, these two add to 7 minus 10 would be -3i. Okay, number 3. Now we've got 2 complex numbers that we're adding together. What do you think we might do there? Any idea, Nick?
Group the like terms.
Yeah, group the like parts together. So we're going to take the 7 plus the -2, which adds to
11. What?
7 and -2. Adds, that's okay. Adds to 5. And then we're going to take the, I'm going to go ahead and cross it out. And then we're going to add the 4i and the -i. 4i plus -i. What does that add up to? Just adding. That's okay. Yeah, so we just add the numbers in the front, 4 plus -1, which would be 3i. Does that make sense? The I, remember, is square root of -1, but when we're working with it, we just kind of treat it as a variable. Yeah. So tomorrow or Monday, we will get to multiplying, but today we're just adding and subtracting. So is this in standard form, 5 plus 3i? Yeah, we've got our real part and our imaginary part. We want to write our answers in standard form. So what do we do first on number 4? That's a little different than... What's a little different on number 4? Yeah, that minus in front of the parentheses. What do we have to do with that minus? Distribute. So this is, remember, this is like plus a -1, and then we're taking a -1 and multiplying it by both of those. So we have -8 minus 6i minus 1. -1 times 1 would be -1, and -1 times 6i would be -6i. Does that make sense? All we did is distribute. What's going on, guys? I'm not talking for very long. Can we just hang on? So now we're going to add our like parts. What would the like parts add up to? Yes.
Wait.
Okay.
On 3, we just did the like terms.
Yes. Why didn't we do anything like this? That's the question. Good. I like the question. Because there's no negative on the outside. So they're just positive, so nothing changes. So we can just add them.
Oh, okay.
So we can ignore the parentheses in this one. Once we distribute this negative on this one, then we can get rid of the parentheses. Good question. So now we're going to add our like parts. Kira, can you tell us what that would be? Good. So she added these two together, get -9. And then these two to get -12i. And she gave it to me in standard form. Perfect. Go ahead and do these. So far. Okay, so do you try? We get negative 13 minus 15i. So many of you did great. I just forgot to put it in standard form. This is something new. You're just learning what that standard form is. Any questions on how I got that before I go on to the last example? We're going to do one more. Okay, so let's do, I'm going to skip to number 7. What would we do on number 7? Distribute, yes. Yeah, so this is a negative. We're going to distribute to both. So 7 plus 5i plus 7 plus 6i. And then negative times negative 6 is positive 6 and positive 2i. And then we add all our like parts. So that's 20 plus 13i.